Okay, today's video is going to be an introduction to Chapter 10, which is called Inequalities. Inequalities. We've done a lot of this before, so this is going to be a pretty quick intro. I'll try to make it a short video. This is section 10.1, and it's called the order of real numbers. Order of real numbers. At first, when we talk about inequalities, we're going to be talking about a number line. Later on, we're going to talk about a coordinate grid, but we'll start with the number line. And over here we have -1, -2, -3, and so on. I didn't space those out perfectly, but they're supposed to be. So when you look at a number line, it shows the relationship between numbers. Any number to the right of another number, so for instance this 2, because it's to the right of this -1, means the 2 is larger than -1. And we can write that in a couple different ways. We can write 2 is greater than -1. We could also write -1 is less than 2. Any one of those is okay. So again, a number line shows the relationship between the numbers on it. So numbers to the right are larger than numbers to the left. Some things we're going to do in this section would be translating into symbols. So we'll get a sentence that looks like y is greater than or equal to any number. We'll try -5. Okay. To translate that into a symbol, you would write y, and then the is greater than symbol. But this is more than that. It's is greater than or equal. And the or equal part just adds a little line under there. Y is greater than or equal to -5. If you wanted to figure out what y could be, well, y could be anything that is greater than, so -4, -3, 100, 1,000,000. So y could be all those. But the or equal to part means that it could also just be -5. So y could be -5. We'll be classifying statements as true or false. So for instance, I might write something like -1 is less than 3, which is less than 2. So this is called a compound inequality. And oops. Sorry, I had to pause really quick there. So we have this compound inequality, and we need to see if this is true or false. Well, in a compound inequality, for it to be true, all of it has to be true. Okay, so notice this part's true, okay, but this part here, 3 is less than 2, is false. That is false. Therefore, the whole thing is false. Okay, that's called a compound inequality. I can talk to you a little bit more about that. If you look at page 457, this is just below example 1. There are times when you want to decide if something is in between something, or you need to put something in between something. For instance, -4 is less than x is less than 2. So if you need x to be in between -4 and 2, we can write it as this compound inequality. So this shows that x has to be greater than 4, but it also, at the same time, has to be less than 2. So you can think of all the numbers that would work here, such as -3, -2, 1/2, 1.5. All these numbers work for x because they fit in between those numbers. You'll also have to determine if things are true using absolute value, because we're going to use more absolute value later on in the chapter. So if I have a statement that looks like this, the absolute value of negative 2 plus the absolute value of negative 5 is greater than the absolute value of negative 2 minus 5. Before we determine if this is true or false, we have to simplify each side. So to simplify the left side, it's pretty simple. The absolute value of negative 2 is just 2, plus the absolute value of negative 5, which is just 5. So the left side is 7. And this sign remains the same the whole way. Well, negative 2 minus 5 is negative 7, the absolute value of which is 7. And then you have to say to yourself, well, is 7 greater than 7? And the answer is no. So this is a false statement. So again, when you're doing those, you need to make sure that you simplify both sides. Now, if this happened to be, let's see, so I'm going to write that in blue actually. False. Now let's change it slightly. If this happened to be a greater than or equal to statement, then this would be true, because 7, although not greater than 7, it is equal to 7. And remember, this is read as greater than, or, that's the important word there, equal to. And so if it's an or statement, one of the two has to be correct for it to be true, and it is. Let's try another example. If I had something like the absolute value of negative 1 is less than or equal to the absolute value of negative 9. Again, to determine if that's true or false, we just simplify both sides. 1 is less than 9, which is true. Not too bad. Now there are times where we want to solve an inequality. And the inequality in this case is going to be 2n plus 2 is greater than 5. Now we could just solve it and using some techniques we know for equations, which we'll show you later on in the chapter. But for now, we're just going to give you a solution set. So if n, and this little symbol means possible values of n, so we use 0, 1, 2, 3, 4, and 5. And you can probably do this mentally. So we'll start with 0. 2 times 0 plus 2 would be 2. So 2 is not greater than 5, so that's not the correct answer. 2 times 1 is 2, so 2 plus 2 is 4. That's not greater than 5. 2 times 2 plus 2, that's 6. That works. 2 times 3 plus 2 works. And 2 times 4 and 2 times 5. So all of those work for this inequality. Now getting to graphing, which I think we did a little bit of last year. If I wanted to graph negative 2 is less than m is less than or equal to 3, I need to put up my number line, and I need to put in the important numbers here. You could fill in the whole number line with all the numbers if you wanted, but it's not really necessary because we put the important ones there. Now, negative 2 is less than. A less than symbol means you're going to use an open dot at negative 2 because that is not included in the answer, and is greater than, or sorry, less than or equal to, we used a closed dot because equal to means 3 is one of the answers, and everything in between is an answer. For instance, m could be 0, m could be 1, m could be 1 1/2, M could be 1/3. So all of these need to be shaded because they're all possible answers. Keeping in mind that -2 is not an answer because -2 is not less than -2, but 3 is because 3 is less than or equal to 3. So that's how you would graph that statement. That should be enough to kind of introduce the chapter and get you started on the homework. If you look at problem number 31, it says graph the inequality over the given domain. Remember, domain is all the possible values of the variable. So if we have 1 is less than or equal to x, which is less than or equal to 6, if I wanted to graph that on a number line, normally I would just put the 1 here and the 6 here, and everything in between if I wanted. Make my close dot here, and shade everything in between. The reason I'm not shading everything in between is because the domain in this case is positive integers. Now, integers do not include fractions, so therefore I do need to write 2, 3, 4, 5, because specifically the only things that I can graph are the integers. Because notice 1.5 right here would not be an answer, because although it would make the statement true normally, because it's only positive integers we're talking about, we wouldn't graph it. So it's only those specific dots. Most of the time the domain is all real numbers that would include fractions and decimals, so we can just shade. But in this case we can't do that. So be aware of that when you get to 31 through 38. So no homework beyond just watching this video. So when you get to class, be ready to answer some of these questions. All right.